We have the pleasure to receive today Jean-Marc Jancovici, who is the founder of Carbon Forum, a consulting firm specializing in the transition to a low-carbon economy. Mr. Jancovici is also the president of the Shift Project, a Paris-based think tank also focused on the low-carbon economy. Associate professor at Mines Paris University, member of the French High Council for Climate. Several books have been written by Jean-Marc Jancovici on the issues of energy transition and climate change. You have also a taste for transmission and scientific popularization, which, while always being scientifically rigorous, like on your website, jancovici.com. I would remind you that Jancovici is here to talk to us all about the transition issues that we have been discussing since yesterday, and I would ask you to give him a very warm welcome. Thank you. And with such a nice intro, I'm done. Jokes apart. So, as some would say before making a lengthy speech, I'll be brief. No, sorry. What I mean to say is that I'm sorry, but I'll have to be brief. Because who in this room, although there's no lights, was born after 1992? So I'm pleased to announce that you are the future generations. No, this isn't a joke at all. When the Climate Convention was signed in Rio in 1992, for those of you who haven't read it, go read it, the Climate Convention says that the level of greenhouse gases in the atmosphere must be kept at a level that does not present a danger to mankind for present and future generations. So in 1992, the future generations were all the people who were not born yet. So all the people who were born after 1992 are part of the future generations. So with this little introduction, you can see that the future generation, there's already a big bunch of them on Earth, and there's no need to wait later to deal with it. So the reason why I'm in this room is this. It's because our planet Earth, despite all the dreams of business plans and greatness we may have, has a characteristic that it's hopelessly finite. Our planet Earth was approximately 13,000 kilometers in diameter 10,000 years ago. It has today a diameter quite approximately equal to 13,000 kilometers, and in 2 centuries, or in 1 century, or next week, or when the business plan that your banker asks you to do comes due, it will still be 13,000 kilometers in diameter. And this very simple characteristics makes that we, the good 8 billion good men on Earth, have a little number of small issues regarding space that we take up in this tiny can that does not want to increase in size. And there are 2 subjects in particular that I want to talk to you about tonight, which are climate and energy. So the optimists in this room will say that there is no point in talking about climate, because in 2015 in Paris, that is to say in this good city, Mr. Fabius, former French Prime Minister, who becomes auctioneer for the occasion, waves his green hammer, hits the table and declares the Paris Agreement signed. So the Paris Agreement says that the world will be saved and that there is no need to worry about the climate. You know, I'm a hardworking little engineer, and a thing that the hardworking little engineers love to do when they hear big slogan like those of politician Mr. Jadot, which you're going to receive soon. No, sorry, I shouldn't talk badly of others. Well, they love to do one thing, which is to go look at the facts. So there's one fact that we can look at, which is actually quite stupid, which is how much carbon dioxide is there in the atmosphere. You have here a curve whose scale starts on the year I was born, which is good because I'm a damn narcissistic. Of course, it's a coincidence. Turns out the graph I found starts on the year I was born. And that gives you the amount of CO2 that there is in the atmosphere. I will explain later how it gets there and why it stays there so long. So, you see, this curve looks extremely regular, and if I had hidden the years on the axes, I could have asked you, where is the point that corresponds to the start of the climate conventions? Because if the climate convention serves a purpose, the point that corresponds to the start of the climate convention must mark an inflection in the way that the curve evolves. Agree with me? Here, if there is something new that affects the outcome of an experiment, then we should see it. So now I show you the answer. Here you see that, well, not in 1992 but 1995 in the good city of Bonn, with a lady whose name you should all know as Angela Merkel, since she was Minister of the Environment at that time. So in 1995, you have the first meeting of the parties at the Climate Convention. That's what COP means, by the way, Convention of the Parties. It means that all the countries of the planet, since every country has signed the Climate Convention, which says, that we need to take care of CO2 in future generations, are meeting in Bonn. And it's a huge success since the convention comes into force. Just look at the graph how the amount of CO2 in the atmosphere evolves before and after the convention. Then you have, 2 years later, the Kyoto Protocol, where the so-called rich countries said they were going to take commitments to reduce their emissions. You see the result. After you had Copenhagen, which according to Mr. Jadot was a big failure, where neither more of a success nor a failure compared to the others. And here you have the convention that was held in Paris, and you can see that for the moment it doesn't mark any inflection in the light of what has happened since. So take this little temporary conclusion. The success or failure of a COP in the media only commits the journalist who wrote the article, and absolutely nobody else. Besides, for the rest of your life, if I have one piece of advice to give you, remember this: what is written in the newspaper is only binding for the journalist who wrote the article and no one else. In other words, these articles are never opposable sources, and the newspaper is never an opposable source. So what you see here is that in fact the COP, the UN Convention, at the moment has no impact on what's going on in the world. And I can come back to this during questions later, but it's actually quite normal when you know how the UN system works. That's not where things are happening. Here you have the reason why greenhouse gases are increasing in the atmosphere is because we are emitting more and more of them. So greenhouse gases have a definition in physics that's very simple. They are gases that have the property of intercepting the Earth's infrared light. I don't have the time today to give you a physics course because I'm too limited, but all you have to remember is that a greenhouse gas is a gas that intercepts the Earth's infrared rays. And among the gases with this property is notably CO2. And so CO2 emissions, we add them to a natural cycle because there has always been a natural cycle of CO2 in the atmosphere because there are plants which have a carbon cycle. And we add it through three processes, which are burning ancient plants, ferns that have been imprisoned in the Earth's crust, which is called coal. We also burn oil, which is made up of plankton that have also been fossilized in the Earth's crust. And we burn gas, which is also plankton that has been fossilized in the Earth's crust. These three fuels are called fossil fuels because they are fossils. They are remains of ancient life that has been fossilized in the Earth's crust. So keep in mind that the typical formation time for these fossil fuels is somewhere between 10 to 400 million years, so it's perfectly renewable if you have a time to wait 15 million years. If you are a little bit more of a hurry, that your business plan needs to come to positive cash flow a little bit faster, well, it's not renewable, and you can consider that you have a starting stock that's given once and for all, and it's not going to increase as you go along. And there are other processes that lead to greenhouse gas emissions, which are not CO2, like deforestation is also CO2. And by the way, we have an accelerated deforestation process taking place in a country called Australia, because yes, a fire is a deforestation. I did a quick computation, great, but very nice, of what has already burned in Australia, and it has resulted in a higher CO2 emission than Australia's annual CO2 emissions under normal conditions. Because all the carbon that's in the forest that are burning is CO2 that's going into the atmosphere. You have methane, which is a different gas than the CO2 that's emitted with cattle, rice paddies, oil and gas development, and there are other pixie dust. So what you see on this graph that gives you the global emissions is that you don't see the impact of the Climate Convention. We also don't see the dematerialization of the economy. If I take any one of you in the room and give you the curve without the x-axis and ask, show me where the economy is starting to dematerialize, it's kind of tough to give an answer. And the last thing that you don't see either is the rise of renewables and the digitalization of the economy, which supposedly dematerializes it. You don't see it. And the reason you don't see it is that it's basically slogans. Digitalization doesn't dematerialize the economy. It takes a ton of CO2 to make the computer I'm looking at. Netflix is as big a carbon footprint as the multinational cement company Lafarge, because it takes servers, computers, a huge chunk of the internet bandwidth, and so on. And renewables, we'll see that later. We'll talk about it much more in the journal than its actual importance in real life. So, reality today is that emissions are increasing continuously without any process that you could read about in the newspaper. Is a process moderating that increase being a reality in real life? And I'll tell you again, every time you have a choice between believing the newspaper and believing the facts, you better believe the facts. Generally, the result is much nicer. Where do the greenhouse gas emissions come from today if I break them down by activity? You have 20% of all emissions in the world coming from coal-fired power plants alone. So coal-fired electricity is 20%, one-fifth of all greenhouse emissions in the world. Conversely, two-thirds of the coal extracted on Earth is used to power an electric power plant. So coal is essentially the energy of electricity. Then there are 6 or 7% that comes from gas power plants, and they're marginally from oil electric power plants because there's very little of them anymore. Then you have 6% that comes from cement plants alone. In a cement plant, you heat limestone, calcium carbonate, you break it in half. One end is CO2, which goes into the atmosphere, and on top of that, you have the CO2 from heating energy. So making cement emits a lot of CO2. Direct emissions from the rest of the industry, so like boilers and blast furnace from the rest of the industries, are like 11 or 12%, among which steel mills are 5%, so meaning that making steel and cement, so making housing and infrastructures, is a big 10% of the greenhouse gas emissions on Earth. So then you have 6% of the emissions, which are boilers in buildings. So in France, it's considerably more than that, more like 25%, because we don't have coal-fired power plants, because we don't have steel or cement at the same level as the world average, because our infrastructures are already built, and because, of course, we're a mid-latitude country that heats up during the winter. But in the world, it's around 6%. Then transport is 14 or 15%, where you have 6 for cars, 4 for trucks, 2 and 2 for planes and boats. So remember right now that coal power plants in the world are a bigger problem for climate than all means of transportation in the world. Remember that cement plants alone emit as much as all the trucks in the world. I don't show it on this graph, but the computer infrastructure is now 4% of global emissions if I put from end to end the manufacture of computer and network components and their operation. 4% is growing by 10% every year, which is totally unsustainable. In other words, right now the digital is already equivalent to the world's truck fleet in terms of greenhouse gas emissions. Eating is 20% of emissions. You have mostly non-CO2 gases, so in there you have cattle, you have 1.5 billion cows on Earth, you have rice paddies, and so on. Deforestation is about 10%. The bulk of deforestation in the world is cutting it, burning it down, and growing crops instead, whatever the crops. And then you have various pixie dusts such as waste management, water treatment, and so on. Refrigeration fluids, and stuff like that. So what you see in this panorama of greenhouse gas emissions is that emissions are very much linked to many things that have become commonplace around us today, like moving around, having electricity, having industrial processes like manufactured objects and so on, and eating, of course. So we are not dealing with an environmental problem that is an individualized problem that you can just give to an engineer, I'll tell him, deal with it, I don't want to hear about it, I'll take care of the rest. Okay? It's a problem that's intrinsically linked to all of what we do from night to morning and morning to night. I'll come back to that later. So one of the characteristics of the main greenhouse gas that we are putting in the atmosphere, CO2, is that it's an oxide. The dictionary is well made, as it's called carbon dioxide. Your old memories of chemistry may remind you, for those of you who do have some, that oxides are molecules that are chemically inert. That is, once the molecule is in the form of an oxide, if you don't give it energy, the molecule stays as an oxide indefinitely. For example, all metals that can oxidize, the metal deposits on Earth are all in the forms of oxide. Like iron, for example, it's in the form of iron oxide. You don't find pure iron. So you have to remove the oxygen by bringing energy. Well, CO2 being an oxide, once you put it in the atmosphere, it doesn't have any spontaneous purge process. So the CO2 feels great and just chills there, you could say. And there are only 2 processes to purge the CO2 from the atmosphere. One is a simple balancing process. It's dissolving in the ocean, I'll talk more about it. And the other is a process that requires energy input. It's photosynthesis. Photosynthesis requires that plants get energy from the sun, If you don't turn on the light in your closet, what you put in there won't grow. So you must provide energy for the plant to work. And it's a slow process. So it only takes place at the ground level. Elsewhere in the atmosphere, it's not happening. Dissolution in the ocean is a simple transfer process, so that means that when the concentration of CO2 in the air is higher than the one in the water, well, some of the CO2 goes from the air to the water. It's just a balancing process. It's not a chemical reaction process. It's just that there are two compartments, like a communicating vessel system, and it goes from one to the other, so which means that it is reversible. It can go back from the ocean to the atmosphere. It's no problem. It has done that in the past. Because of this very, very high chemical inertness of CO2, something that you have to keep in mind, because it will structure the rest of what you have to live, as it will for me, is that from the moment we stop emissions, the excess of CO2 that we have already created, after 1 century, still half of it will still be above our heads. It will have decreased a little bit, but still half of it is left. After 1,000 years, there's still 20%, and after 10,000 years, there's still 10%. I'll tell you in another way, and like video games that you love, when it comes to climate change, there's no reset button. When you lose, you've lost. It's over. No reset button. You can't just say, if I had known, I wouldn't have done it that way, let's have a redo. And because of this very, very great inertia of CO2 in the atmosphere, you have to know that when my generation, when it starts to take action, that it should do, but it's not doing enough right now, it's actually working for your generation. In other words, the climate drift of the next 20 years is totally embedded in the emissions that have already taken place. There's absolutely nothing to do about that. So the climate drift of the next 20 years is totally sealed because of the emissions that have already happened. So any emission reduction that starts today is only good for the next generation. Better than nothing, of course, but remember, it means that on this topic we're always working for the next generation, which is obviously a huge problem in the short-term systems that we've built, which are filled with things you love, like quarterly accounts or stock exchange listings. These are systems that shorten the time frame in an absolutely considerable way. Here, we're talking about processes that are taking place on timescales that are beyond comprehension and that exceed, above all, the electoral deadlines that we have put in place. So here, I refer to you to the good readings, such as Tocqueville, who explains how democracy is a terribly short-term system that is very poorly equipped to face these kinds of problems. So part of the greenhouse gas emissions are coming from energy, and the emissions coming from energy are increasing because energy use is increasing. Here you have energies that have been used by mankind for the last century and a half. What immediately jumps out to you normally when you see this graph is that on a global scale, there has never been a substitution between energies. The energies that we use have piled up on top of each other, always. What you see is that coal has been added to biomass, oil has been added to coal, gas has been added to oil, and so on. And the new renewables that we are so excited about right now, solar, wind, etc., are adding to the rest. They are absolutely not substituting them on a macroscopic scale. It's just piling up. If I ask you what you think has increased the most in energy supply over the last few years, I am ready to bet that a significant part of the room is going to tell me, oh, come on, over the last few years, what has increased the most is renewable energy. Wrong. You have a graph here that gives you the variation of the world energy supply since the year 2000. If I had showed you since 2010, it would have been the same, which shows you that still today, the energy that in absolute value increased the most stay the fossil fuels. Over the last 18 years, the energy that has the most increased is coal. Clearly, it's the electrification of China with coal power plants, followed behind by fossil gas, although apparently some say it's going to turn green, then followed by oil. And what you see is that the wind and the sun are way behind, and in fact, if the news had a pagination proportional to what has been happening in the world over the last 18 years, well, for every article about solar, they should have been made 11 about coal, which I don't remember them doing that. And you know, funny story by the way, windmills, we have known about them for 2,000 years. We had water mills all over the Roman Empire. So 2000 years ago, wind power was very well known. And if wind power is so much better than fossil fuels, which is what some of its proponents are saying today, why did we bother switching from wind to fossil fuels? It was a hell of a lot better. Well, there was no reason to do that. Actually, when you look at history, you realize that what has happened is the exact opposite of what is sometimes presented as the obvious. A few centuries ago, we had a 100% renewable navy. Here's a 100% renewable boat made of a renewable wood with renewable cotton and linen sails, driven by perfectly renewable sailors and galley boys too. Sometimes they also had a renewable scurvy. But we said no, actually, to supply the local supermarket for cheap, it's much better to have fossilized marina. So we're going to fossilize the navy. We had perfectly renewable land transport. Here's a renewable wooden cart. Okay, no, I'm cheating. There's probably 2 or 3 fittings in there aren't. But whatever. With a renewable horse eating renewable grass. But still, to fill the supermarket with sail, like it was better to fossilize it. We had a renewable agriculture with renewable tractors, which are called ox and draft horses. That's why there were horse butcher shops, by the way, and they were eating renewable grass and so on. And so we said, no, to get cheap McDonald's or any other brand, who cares, it's going to be much better if we use fossil-based agriculture. We had public works that were renewable. It took a bit longer to make the Roman roads, of course, but that's life. Now to make roundabouts in French, which are really important, we use fossil backhoe loaders because it's more efficient. We had renewable construction, so it took a good century to make Notre Dame version 1. Of course, version 2 is going to be faster. Today, to make big pickle-shaped buildings at La Défense, by the way, I'd love to psychoanalyze the architect, we're going a lot faster thanks to fossil energy. We had renewable industry, as you see with this renewable water mill. We said, to make cheap Christmas toys, it's much better to have a fossilized industry, so we fossilized it. We even had renewable dryers, which were called the sun, but now we have gas dryers. So it's been 2 centuries since we've been doing the exact opposite of what is presented today as an obvious on the economic level, on the ecological level. We are hearing stuff like renewables are the future, they are cheap, etc. Except that it's been exactly 2 centuries that we've done the exact opposite. So there must be a small reason, which is physics. So to understand this physical reason, we're going to take a little detour by the Eiffel Tower. Who's ever walked up the Eiffel Tower? Not with the elevator, on foot. Taking the stairs. Once. Who's done it 6 times? In a row? No one. So my computation works if you do it 6 times in a row. So imagine that you climb 6 times in a row. Well, Miss Lady here weighs probably less than 80 kilograms, but that doesn't matter. My computation works in orders of magnitude. So you do it 6 times in a row with a small picnic in your backpack, which makes you climb 2,000 meters or 7,000 feet in 1 day. You're going to do this with your legs, and your legs are obviously going to provide energy. The energy that it provides is to lift your body up against the gravitational field. That's what they do. Well, doing this exercise, which normally you don't do every day, you're going to provide a mechanical energy which is of the order of half a kilowatt hour or 1 million joules, which is what you're going to provide with your legs with 1 day of hard sweat. If you do this every other day, so at the end of the year you'll be super trained. I hear, by the way, that there are races like this, to ascend lighthouses, buildings. Anyways, you'll be very well trained, and at the end of the year, your legs will have provided mechanical energy of the order of 100 kilowatt hours. So that's what you need to keep in mind. A man in forced labor is able over the year, using the most powerful muscles, that is, his legs, to provide 100 kilowatt hours of mechanical energy. If you take my public works worker from ancient times and make him dig out a few tons of dirt during the day, so for example, I took 6 cubic meters, that is to say 15 tons, not bad. He's going to have nice blisters and a bad back at the end of the day. And he raises it for 1 meter, then he's going to be 10 times more ridiculous than the Eiffel Tower climber and providing 0.05 kilowatt hours of mechanical energy. If he does it every other day, 10 kilowatt hours for a year. So at this point, 10 or 100 kilowatt hours might not mean much. Where it's going to mean something is that if you burn 1 liter of petrol, which, as you know, is way too expensive, as the Yellow Jackets say, well, if you burn 1 liter of petrol, you will release 10 kilowatt hours of thermal energy. So once it goes through the engine, you'll be left with 2 to 4 kilowatt hours of mechanical energy.
So in 1 liter of petrol, which costs the outrageous price of €1 something, you have the same capacity to transform the environment as with 10 to 100 days of forced labor of a human being. 1 liter of petrol. So notwithstanding the fact that France is an all-nuclear country, as some say, every Frenchman consumes several hundred liters of petrol on average each year, of the order of 600. Now, if we're talking about money, because that's the only thing you're interested in this university, I know that. Well, if you take my worker, my slave, my mechanical energy supplier, you'll see, in fact, I'm going to explain that talking about money is not interesting. That's the problem. It's an extremely reductive convention of what's going on in the world. If you pay the person who provides you the energy, that is the transformation of the world, at minimum wage, you will pay your kilowatt hour of mechanical energy between 100 and 1,000 euros, whereas the machine provides you the same service with a marginal cost of tens of cents. In other words, when you go from man to machine, and that, which is exactly why we've abandoned renewable energies, that's exactly why we've abandoned them, you are able to divide the cost of a unitary transformation in the environment by a few hundred to a few thousands. That is, the cost of going from wool to a sweater, from a textile fiber to a garment, from metal ores to leg chairs, etc. All that has been divided by a few hundred to a few thousands, thanks to the advent of machines and energy. So what I'm telling you is something very simple, that your purchasing power and mine and that of all the French and of every person in the world today is based on energy. That's what energy has brought us, the explosion of our purchasing power. People were not dumber before we discovered fossil fuels, you know. Some were even smarter than anybody in this room, but they didn't have fossil fuels at their disposal. So they didn't have purchasing power for everyone. What made purchasing power for all was energy. That's even what freed the slaves. If you take a slave, which normally is not a youthful vocation except for a few people who don't shout it from the rooftops, you're going to have to go and get that person against his will, which is going to cost you some money. Feed him, because otherwise you'll lose your asset, prevent him from killing you like in Django, which is going to cost you money, and prevent him from getting the hell out of there, or both at the same time like in Django.
So, if you put together all the costs of owning a slave, who is going to provide you a service, you realize that it's going to cost you 10 to 100 times more than the machine, which is not part of a union, sometimes the driver, yes, but not the machine, who works 24 hours a day and has absolutely nothing against its condition as a machine. So the reason why we have gone from man to machine and from renewable energies, which are much less dense than the fossil fuels, to fossil fuels, it's because it has allowed us to increase indefinitely our Superman costume. So today, energy actually represents our Superman or Iron Man costume. And it's not a costume that you put on in the morning and the light shines in the middle, but actually it's an Iron Man costume that is made up of all the trains, the airplanes, the washing machine, the rolling mills, the cement works, the tractors, the combine harvesters, refrigeration machines, etc. In short, all the machines that we are currently having in the world and that work for us while we're busy telling stories in this room. Because that's what we're doing. We're telling each other stories in this room, while the machines are working and they're preparing your food. If I look at the power of the machines installed in the world today, that is to say, all the machines that I have talked about on top of those that I have not talked about, which eat their own food, which is called energy, well, at any given moment in the world, the power of the machines in operation is several hundred times the muscular power of humanity, and in the Western world it's closer to 1,000. So what I am telling you is that today the production is not made by people, but it is made by machines. So what will make the success of your business plan is not people, but machines. The reason why the French GDP has been temporarily higher than the Chinese GDP, while the Chinese have always been considerably more than the French, is because there has been a time where French had more machines than the Chinese. Period. What makes production, and I'll come back to that later, is machines. So that comes a little bit in opposition with the economics courses you learn here. The economic courses you learn here are based on a postulate that was put forward 2 centuries ago by a number of economists, including Mr. Jean-Baptiste Say, which you have here. And these economists said that nature is worth 0. Okay? What nature gives us is free. So I'll take a silly example. There's 20% of oxygen in the atmosphere. If I take out the 20%, well, so let's be clear that these 20% of oxygen aren't in any profit and loss statements of any company whose business plan you're going to make. Agreed? You've never seen a load line with the oxygen in the air. Well, I don't know. If you've seen it, maybe you should need to stop drinking. Otherwise, no. So it's free because it's not in any load line, except that if I take out the oxygen from the air, you'll all die, there'll be no more businesses, no more profit and loss accounts, etc. So it's something that's free and essential, and in fact, everything on Earth is free and essential. The climate system is free and essential. The existence of oceans is free and essential, and so on. So we could have fun looking at how much it's all worth. I'll give you this little computation which I find funny. You have here the second home of French astronaut Mr. Thomas Pesquet, that is to say the International Space Station. So the International Space Station is worth $100 billion, and it's an apartment capable of housing 6 people, which means it's worth $15 billion per person. Everyone agrees? So what's the use of the International Space Station? It creates, in a place where it doesn't exist, a pressure of 1 bar, breathable air, and a beginning of a water cycle. That's all it can do. It cannot even grow carrots. You can't grow a carrot up there. It doesn't grow wheat fields. You can't even have fish to eat. None of this exists up there. It just creates an atmospheric pressure, breathable air, and a beginning of a water cycle. That is worth $15 billion per person. So I'll tell you that planet Earth, which gives us a breathable atmosphere, a pressure of 1 bar at ground level, a water cycle, and much more, since we can catch fish, grow carrots, go for a walk across the beach. It's at least worth $15 billion per person. Agreed? So if you take the fraction of a planet that we destroy every year to feed our economic system, it's at least 1 per 1,000, which means that every year we destroy at least 1 per 1,000 of the fish stocks, the oil stocks, the gas, the ores, the species, and so on. So the accountant comes by and says, well, you're destroying 1/1000th of something worth 15 billion, you're going to have me a depreciated allowance of 15 million a year per person. Agreed? So on the other hand, you have a GDP that's worth $15,000 per person per year. So you see, I'm explaining that if we take an economic convention that's no more stupid than any other, our economy is a machine to lose, to burn cash that we don't get, and we don't get rich, in fact. It's a machine to burn cash 1,000 times faster on the side of what we lose than on the side of what we gain, with a simple economic convention derived from the cost of the International Space Station. So the fact that our economy today is a profitable system for people is a conventional view. It's not a reality. The reality is that there is a short-term material comfort, but the fact that the long-term global balance is a good deal, it's clearly conventional. So let me rephrase. We considered that nature is free and therefore infinite. That's what Mr. Say said. And therefore, if it's infinite, it cannot be a limiting factor of a productive system. He says that the 2 limiting factors of production are human labor and human capital, and this is enough to fill the supermarket. So anyone who comes by and is interested in physical flows will tell you to fill the supermarket, you may need to have resources to make the products in the supermarket. It's complicated to go to Zara. If Zara is only selling you a concept of clothes, it's better if they sell you actual clothes. And so those clothes are made out of material. These materials you need to find somewhere. They're called resources. And it's either vegetable fibers or a piece of oil if you're wearing synthetic fibers, like anyone in this room wearing synthetic fibers is wearing oil. And then you need to have a capacity to transform those resources. That's labor. And that capacity to transform resources is made for a very small part with the muscles of men, and most of it is transformed by the machines. In this story, capital is a simple inside loop of the system, because this building, which is an element of capital, was made exactly the same ways as your socks, transforming natural resources. Understood? Same physical processes. There, you understand that there are other limiting factors that come into play. If you don't have enough energy to power the machines, I may have a lot of people who agree to get up in the morning because Mr. Macron has persuaded them, and lots of very nice bankers to invest because Mrs. Lagarde has persuaded them. If I don't have enough energy to run the machines, I'm not going to have enough GDP, even if there are lots of men and compassionate bankers. And if I don't have enough resources to transform, same results. And even if I have enough, it's still today the first limiting factor of economic activity So I present to you, and don't go to macroeconomic classes, it's no use. Here's the only macroeconomic model that you need to keep in mind, because it works very, very well, and it has always worked well since I started using it.
The macroeconomic model I present to you says that the GDP in the world, so that is to say the economic value of the resources that have been transformed, because that's GDP, right, is a quasi-linear function of the amount of energy we use. That is to say the number of machines in operation. So count the number of machines in operation, which is measured by energy, and you have production, and you're done. No need for me to bother you any longer. But it leads to the drama of the climate negotiations, since the bulk of this energy is fossil, and as we're going to see soon, we're not about to change that. Well, we've got the same quasi-linear relationship between GDP and CO2. So the very, very good news I bring here today is that for us to get through the climate problem, most of your business plans are going to need to be in line with a recession. Do I need to repeat, or did everyone get that? Very well. That's what it means to get through the climate problem. If we do that, we have a very small chance, and we'll see the pace, to stay below the 2 degrees. If we don't do that, we'll go over the 2 degrees, and things are going to get regulated through disaster, which works very well, as history has shown. So the story of the 20th and 19th century is very, very simple. We have below ground fossil fuels which are free, like all natural resources. So oil is as free as the wind. Nobody in this room has paid anything for oil to form. These fossil fuels provide an energy supply that gives us the ability to transform anything, and that's also free, by the way. And it has allowed us to make all the things that surround us. The socio-economic system, which is the basis of labor productivity, which is nothing more than machines being attached to people. The increase of labor productivity isn't that you've turned into Shiva with 253 arms and 96 legs, it's just that we've added machines that work for you, but we've left man in the denominator. So it's just a normative artifact. The fact that labor productivity has increased. Your muscle power hasn't increased, right? And we are used to account what we do economically and call it GDP. So there are many limiting factors that apply, as I've said earlier. Here are 2 on which I will detail further. The first is climate change, which is a limiting factor. If there's too much of it, will prevent the system from working correctly. And there's a second limiting factor, which is already at work in Europe, which is a bottleneck on the fossil energy supply, which is to say that the fossil energies, well, since they are not eternal, where you cannot eternally extract more and more of them, there's a point at which you start having problems. To be more precise, if you consume from a starting stock which is given once and for all, which is the case for oil, gas, and coal, you agree with me that you cannot have an indefinitely increasing extraction from that stock. Mathematics forbids you to do so. You cannot even have an indefinitely constant extraction from that stock. Mathematics also forbids this. In fact, mathematics force you to have an extraction which looks like that. That is to say that it starts from 0 if you go far enough into the past, which can easily be verified. It will end up at 0 if you go far enough into the future, also easily shown. Worst case scenario, in 4 billion years, mankind disappears beneath the red solar giant, and we'll be sure that there is no more oil extraction, but well before that it'll stop. And between those you'll have an absolute maximum, which is called the peak. And this peak takes place for oil extraction, but also for copper ore, tungsten, thallium, boron, vanadium, chromium, etc. As soon as you take something out of the Earth's crust and that has a starting stop given once and for all, you'll have an annual extraction maximum of this resource. In December 2018, the International Energy Agency released a report that you can see here, on which it is explicitly written that, and of course the French press has hardly talked about it, that the maximum for extraction of so-called conventional oil, that is to say what is not shale oil in the United States nor oil sands in Canada, was passed in 2008. Who in this room has heard about it? I can see 3 there, 4, 8. All right. I can tell you that this is considerably more structuring for the pension system than the negotiations that are currently taking place in France, which we're being told about night and day. Because this structures the total amount of cash that there is to split among us, and if the total amount of cash that there is to split decreases, we can do all the rain dances we want on promises of increasing the index point of whatever, there won't be more cash.
Alright? So the pagination of the newspaper should have been reversed. We should have talked to you all day long about this and from time to time about what's going on in the pension negotiations, but I assure you that it's not going to be the problem. Your pensions, even mine, the problem is not going to be the current negotiations. It's going to be this. If you look at everything that we can take out of the ground in liquid form, so including shale oil, etc., I'll make it short but good. Basically, the total maximum is not 2008, but in the 2020s. And oil is the most limiting energy within all energies because it controls transport. And what you see here is the variation since 1965 of the quantity of oil that we take out of the ground. Note that it's the quantity, not the price in red, and the GDP per person in blue. What you can see is that since the oil crisis, we have limited ourselves to the maximum with what we can do on oil, that is to say we have scraped efficiencies everywhere. Well, both are perfectly in sync, and when there's a time lag, it's the oil that varies before the GDP. So it's not because there's growth that comes from Mars that we buy more oil, it's because there's more oil that there's more machines that can trade between themselves, so the production increases, and vice versa. And there's no link between volume and price as far as oil is concerned. So that's the second thing you can learn here, which is totally wrong when it comes to oil, and in fact totally wrong when it comes to lots of things. You have here a graph in which I put on the x-axis the amount of oil bought on the market a year, which is basically the quantity produced, and here the price per barrel. If you have a price volume elasticity, as we can learn in school, the points should be arranged like the dotted blue line, like this. The less you have, the more expensive, the more you have, the cheaper. It's the famous thing they teach you in school. What you see here looks nothing like that when it comes to oil. You have a kind of spaghetti dish, and in fact, if you look at the history, you can see that for 50 years you have a volume that varies considerably with a price that remains constant. Then you have a volume that hardly varies with a price that goes crazy, and same thing here and here. You will not see the rarefaction of oil by the fact that the price goes up indefinitely. That's not how we're going to see it coming. You're going to see the oil becoming increasingly scarce because the capex per barrel extracted per day increases indefinitely. That's true, but not the price. Because of the peak in conventional production in 2008, Europe's oil supply has been constrained since 2006. I'm going to speed things up a bit because the clock is ticking. So in Europe, oil supply today is constrained. Gas supply in Europe started decreasing in 2005 because the North Sea, which supplies us most of our gas, started decreasing in 2005. It's the peak of production that has passed. Oil has been decreasing in Europe for decades because it's been 2 centuries since we explored our coal stocks, which was long before we started taking care of climate change. And so if you add coal, oil and gas, which make up 75% of Europe's energy supply, all that has started to fall since 2006. You add nuclear power, which is being voluntarily reduced in the wrong reasons in my opinion, but we do it anyways. It won't be the new renewables energies you have here that will compensate this decrease in a significant way. So you see on this graph 3 parts for the energy supply per person in Europe. First, up until the oil crisis, there's an increase. It is starting this moment that economists start to say, where did productivity go? Well, productivity went into the fact that energy, that is the number of machines in operation per person, has stopped growing. That's just where productivity went. Then you have 40 years when it's constant and the economy is struggling a little bit, debt increases, productivity doesn't increase as fast, unemployment starts increasing, etc. And then you get a second bang in the bus when it starts to drop in energy supply per person. And at this point, it really starts to go off the rails. Debt explodes, unemployment starts to rise significantly. You start to have asset inflation everywhere when you start to do quantitative easing, etc. And you see negative rates come up. Basically, the system goes really off the rails, and it's just the start. And if you look at the variation of GDP per person over these 3 periods, you see that before, when the energy per person increases rapidly, we were at 4% per person per year. When the energy stops growing, we are only at 2%. And there's already a beginning of inflation of assets, and since 2006 we're almost at 0, and you ask the British if they like it, and they say no. As far as climate is concerned, the main idea of what I'm going to tell you holds in this map. You have here a representation of the ecosystems installed in Europe before the beginning of climate change, so that is to say in the middle of the 20th century. What you see is that if you take the ecosystems and you don't remove them to do lots of futile things like fields and roads, or essential things like this university's campus, well, you have essentially forests. So that means that everywhere in Europe, it rains enough to grow big plant species that are trees. Here's what Europe looks like 20,000 years ago. So 20,000 years ago, obviously this university doesn't exist. Humans are a little less numerous, and we are at the heart of the last ice age, so it's a lot colder than today. The climate has varied spontaneously. Man is not the only one who makes climate vary. We make it vary very fast, too fast, but it varies more slowly naturally. And so you see that the European geography looks nothing like it looks today. So there's no further abroad in Sweden, so forget about that, because Scandinavia is covered with 3 kilometers of ice, exactly like Canada, tabernacle, as we would say. Since this ice was formed by taking water where it is available, that is to say in the ocean, and that the bottom of the ocean has not changed because it's still at the same place, the ocean level has fallen by 120 meters, so your grandparents would not have lost all their savings in the Eurotunnel. There was no need of building this Eurotunnel between France and UK because the channel is just not there anymore. The Scots don't bother us in rugby anymore, the Irish still do, unfortunately. It is much colder and therefore much drier, and you have no forest, almost no forest in Europe. All you have is steppe and tundra. In this kind of ecosystems, you manage to keep alive 100,000 good men in France, so the French population at the time is a small Parisian district. When the Earth passed from the last ice age to the pre-industrial era, the ecosystems in Europe have gone from this to this, and obviously the temperature has warmed up. And well, the global warming corresponding to this transition is 5 degrees in 10,000 years. Before detailing very quickly the consequences of climate change, just remember this concluding sentence: 5 degrees in a century is war everywhere. That's exactly right. 5 degrees in a century is war everywhere. That means that the destabilization of environmental conditions will go at such a speed. On top of that, in a world which in the second half of a century will begin to be in a forced state of energy contraction, that is to say with less means to react to adversity, it is absolutely obvious that the way the system reacts is by creating conflicts and tensions absolutely everywhere. Some examples. Here you have the number of days that will be lethal, that is to say, it will be physically impossible to survive in the year 2100 with a temperature rise of 4 degrees. The reason why it's so concentrated near the equator is that it will be so hot in these places with such a high humidity that you will not be able to sweat to evacuate your heat and you will die of hyperthermia. Too hot. Okay? Well, you can see that in some places it will be all year round. Here, 50 days a year. Here is a graph that comes from the latest IPCC report called Climate Change in Earth, and it tells that starting 3 degrees of temperature rise, there is a widespread food insecurity throughout the planet. And a widespread food insecurity is a widespread violence. It's a constant throughout human history. Greenland has started to melt, and West Antarctica is in danger of destabilization if we go beyond the 2-degree trajectory. West Antarctica will probably end up disintegrating. That plus that is going to be 9 meters more in the ocean in a few centuries. So it's a couple of centuries, but the finger on the trigger is right now. So I won't detail the conclusions, I'll just finish with the dilemma that we have. Here is a second important curve that gives the temperature response of a climate based on the total amount of CO2 that we're going to put in the atmosphere between the pre-industrial era and the year 2100. Okay? By end of 2018, 2,200 billion tons of CO2 have been put into the atmosphere, which guarantees a temperature rise of 1.5 degrees. So actually the famous 1.5 degrees, which are sometimes mentioned in political commitments, in company speeches, etc., saying we're going to do what's necessary, in fact, there's nothing we can do about it, they're already lost. If we want the 2 degrees, we need to limit the cumulative emissions by the year 2100 to 3,000 billion tons of CO2, of which 2,200 have already been emitted. Which means that by 2100, we still have the right to emit a third of what we have already emitted in the past, no more. while we're going to be on average 3 times as many on Earth. So it means that the carbon footprint of each person in this room has to be 1/10 of your grandparents' carbon footprint over your whole lifetime. That's the 2 degrees. That also means that by 2050 you have to divide global emissions by 3, which is another way of saying that they have to decrease by 4% per year. So any business plan that is not compatible with a 4% per year decrease of global emissions is not acceptable in terms of climate preservation. I can tell you that it's just about any business plan that you'll do, just about any of them. So the situation we're in is that today we're sailing between 2 risks. There's a man called Mark Carney who published this, who talked about these risks just 3 years ago, just before the COP21. Either we don't care in the short term to control the greenhouse gas emissions by saying, as long as we can, let's take advantage of it, and then we'll irremediably have, because of the inertia of a system which we can no longer avoid, physical risks that may affect the life expectancy of a large part of the population on Earth. Or we're going to tighten our belts very, very fast and say this way we'll avoid major climate risks, and we're basically causing a major global recession. It's either one or the other. It's not both cheese and dessert, unfortunately. In this matter, companies obviously have a role to play, and I'm going to finish with that. You know, today, there's a lot, maybe there's some people in this room who have signed the Students' Manifesto for an Ecological Awakening, and I'm going to say some unpleasant things, but there's lots less of these students in business schools than in engineering schools. I wonder why. That's the way things are. And under this manifesto, there is, on the manifesto side, there's a little anti-greenwashing guide, which I advise you to go read. It's funny. Today, you don't have a single company that doesn't tell you sustainable development, it's really important, etc. I will do everything to be 2 degrees, whatever, and so on. So I say, okay, these people can tell me exactly what they want. I don't believe for a second what they tell me until they have at least made the list I'm going to show you now. You've all heard climate change 1,000 times. You may have heard it 1,000 times. I think that there are still very few people in this room who are able to describe to me exactly what it's all about. That means what are the orders of magnitudes, the time constants, the causes, the processes involved, etc. I don't think so. And you can't properly treat a problem until you are properly able to describe it. That means until you can properly describe a problem, what you think is a solution is in fact a random draw. And when you draw randomly, the probability that you will reach the target is extremely low. Today, this is exactly what's happening in the economic and political world. That means that people who make decisions have a lack of knowledge on the problem at hand, which is major, particularly for demagogic reasons, but not only. And therefore they draw randomly. And my personal opinion is that to begin to understand what is going on with the stories I have briefly touched on this evening, you need to take 10 to 30 hours. Since carbon is not present in the euros, you are not able to understand how far you are from the problem until you have an accounting system that is adapted to the problems to be dealt with. So your monetary accounting tells you absolutely nothing about where you are with the climate issue. Nothing. So until a company has done detailed carbon accounting that allows every manager in the company, meaning you in a couple of years, to be able to compare the monetary and carbon characteristics of the decision to be taken, you are not equipped to navigate in such a world. And this concerns almost no company in France. There's almost none at this level. Then, I don't know any company, with a few rare exceptions, that has today a long-term strategy. Well, when they have long-term strategies nowadays, it's pretty amazing, but has a long-term strategy that is compatible with a 4% drop per year in emissions, which means that it very quickly constrains the available means of transport, the available means of production, the purchasing power of consumers, the geographical locations that remain accessible, etc. Obviously, you have to look at the whole value chain. I hardly know any company who's done this. When companies say that they're going to set targets, they generally take them per unit of output. So they say, I'm going to reduce, well, like typically Air France the other day, I'm going to reduce my emissions per passenger kilometer. But at the same time, they want their passenger kilometers to increase faster than the unit decrease in emissions. I don't call that solving the problem. If you say, I'm going to drink less per hour, but a lot more often, it's not completely excluded that your liver is going to get worse anyway. And finally, the process has to be piloted. So if you don't have, for these matters, an executive committee member spending at least 25% of his time, then it is being treated in an offhand manner. The last point is that in all companies that have variable shares, and there are quite a lot, if this matter is not in the variable shares, then the subject is not being treated seriously. So here, I'm giving you all a very tiny subset, because there's obviously a whole lot more to it than that, which is essential for a company to start pretending that it is doing serious things on the issue. While it hasn't done all of that, I'm not even interested in listening. Well, I'm interested in working with them, that's my job, but I'm giving almost no credibility to these public statements of its self-proclaimed virtues. There, I'm at the end of my time, I'll stop. Thanks a lot. Thank you, Mr. Jean-Marc Jancovici, for coming tonight.